1 degree Celsius warmer today than we were 100 years ago on the planet. She says, well, that sounds nice. And not realizing that the difference between the temperature we have today versus an ice age is about 5 or 6 degrees Celsius. So being up 1 degree Celsius over a period of 100 years is a really big deal when you think that the difference between what we have now and an ice age is 5 or 6 degrees Celsius. And by the way, if I can get to the next slide, my little clicker here is not working. Oh, good. As long as I'll just say click and then you click, okay? Good. So this is not, by the way, when I talk about that we're 1 degree Celsius warmer on the planet, this is not my cavalier opinion. This is the opinion of the group that authored this document on the left-hand side of the page, the Intergovernmental Panel on Climate Change. It's a group of several hundred climate scientists from all around the world who do nothing else 7 days a week other than study climate science. That's it. This is the authoritative body on the planet that looks at the climatological reality of our situation. And they have determined that yes, we are 1 degree Celsius warmer, and it's through the burning of fossil fuels that has driven that increase in temperature. And indeed, on the right-hand side, where I have the material written in italics, it's a direct quote from the report. It says, they said, it is extremely likely, which in science nobody ever agrees on anything, so this is big. It is extremely likely that human influence, which means the burning of fossil fuels, has been the dominant cause of the observed warming since the mid-20th century. Now, when we say we're 1 degree Celsius warmer, that means on average, that means some areas can be up 2 or 3 degrees Celsius and other areas might be cooler, so that's an average. But if you think back to your grade 9 science, this is important, the warmer temperatures particular, and we're realizing them in southern Canada, we're up about 2 or 3 degrees Celsius on average across the southern base of the country over the period of the last 100 years. And when you think back to your grade 9 science, for every 1 degree Celsius increase in temperature, the air holds 7% more moisture. There's more water in the air. So if you're up 2 or 3 degrees Celsius and you're holding anywhere from 10 to 15, 20% more moisture in the air, and by the way, all the energy that went into evaporating that water in the first place, it's still there. It didn't disappear. When that water comes down, when it condenses, it comes down in the form of precipitation. It comes down with a lot of ferocity, a lot more water. The energy comes out of the system. So when you see these big storms coming down today, when you have this perception of the storms being bigger and more energy attached to them, they actually do. That energy is there. There's more water coming down with more energy over a shorter period of time due to the fact that there was more water put into the moisture through evaporation as driven through by climate change. Now, the manifestation of extreme weather events, it's in the form of, yes, flooding, but in other places we have droughts, we have fires, we have hail, we have permafrost loss. We have a multiplicity of factors that as a result of climate change, we have to learn to adapt to now. We have to figure out, as we've been discussing, for example, and I'll just stick with one feature, flooding, we have to figure out how can we build communities going forward, or how can we retrofit existing communities, or at the end, I'm going to come down to your individual house. What can we do to protect these systems from the more water that's in the system now, the flooding that's occurring? But we have to think about when we build new subdivisions going forward, not only do we have to build them with features in place that deal with the more water that's in the system now, we also have to think about the fact that if we're going to continue to burn fossil fuels on this planet going forward, not only do we have to plan for the extreme weather that's happening today and the big storms happening today, we have to also plan on the bigger storms that are going to come in the future. Because when we're building buildings or subdivisions or whatever it might be, we're building stuff that virtually has zero capital stock turnover in human terms. In other words, you're building it today to be here 25, 50, 75 years down the road. And we want to make sure that even if you build this building today in an area that's not flood prone, you want to make sure that you're not going to be sitting in the middle of a floodplain here 25 or 50 years down the road. So, that is water, by the way, it's not gin or something. A fundamental question that we have to ask also in terms of preparing for climate change and to make sure we build right is, if we're going to continue to burn fossil fuels on this planet going forward, we also have to build in such a way as to anticipate that future and build it right today, so that we don't build it wrong and then have to rebuild again later in the future. So the fundamental question is, are we going to continue to burn fossil fuels on this planet going forward? Next, click. Click again. Yeah. Now, so what you're looking at here, and this is all data from the International Energy Agency, which is the preeminent agency in the world that looks at energy use on the planet today. So what you're looking, in the lower left-hand corner, we see 1980, over to the right, 2030, and here we are at this vertical bar, 2018. And what the different colors on the chart show is the energy usage on the planet today. Where do we get our energy? And it's this point that's meaningful, right there. Right now, as of this moment in time, we get about 80 to 81% of our energy on the planet, up to this point here, from about 1/3 each of coal, oil, and natural gas. About 81% of our energy on the planet as of this moment comes from coal, oil, natural gas, 3 fossil fuel-based sources that when they're burnt, they release carbon dioxide, greenhouse gases into the atmosphere. And then at the upper part of the chart you see right now, we get a little bit of extra energy from nuclear, hydro, biomass, and there's a red sliver at the very top. That's what solar and wind contributes to world energy supply. It's virtually immeasurable on a global scale. Now, what the International Energy Agency has done, they have forward projected to 2030. And they said, what will energy usage look like on the planet in 2030? And you can see that we still will have about 80% of world energy supply will come from a third, coal, oil, and natural gas. But the footprint, the greenhouse gas footprint, will be about 15 to 18% greater. And that's because between now and I told you all this is depressing, right? Okay, that's because between now and 2030, we are going to add about 1.5 billion new people to the planet beyond what we currently have, driven through something called population momentum. So right now there's about 7.5 billion people on the planet. By 2030-35, in that zone, we'll add another 1.5 billion people to the planet. So just to put that in perspective, if you go back to the time of Christ, so 0, there were 250 million people on the planet. It was empty. It took from the time of Christ to 1930 to get 2 billion people on the planet. It took more or less 2,000 years to get 2 billion people on this planet. From 1930 till now, we've added 5.5 billion people to the planet. In 88 years, we've added nearly 2.5 times as many people to the planet as what previously took 2,000 years. And then between now and 2030, we're going to add another 1.5 billion people. So at the root of a fundamental cause at the root of our problems is population growth. Right now, the world's population increases net by about 11,000 people per hour. Every single hour, there's 11,000 more people on the planet if you subtract deaths from births. And so if we sit in here for 2 hours, at the end of the 2-hour session, we've added, more or less, we're up about 22,000 people on the planet. So this is the reality we're facing going forward. We should be doing everything within our power to mitigate greenhouse gas emissions, to lower our carbon footprint, for sure. But we also really have to recognize that we have to adapt to the extreme weather that's in the system today and that which is coming guaranteed going forward. We have not had flooding in Canada yet compared to that which is coming, so we need to prepare. And I told you, it gets better in a minute. Okay. So, and Diane alluded to this chart, and I'm just going to say just a little bit more about it. By the way, there's only 1 or 2 more slides here. So what you're looking at, just again as a reminder, is in the lower left-hand corner we have 1983 over to 2016. And these orange bars depict catastrophic insurable losses realized in Canada on an annual basis. And a catastrophic event in insurable terms, this is money paid out by insurance companies for things going wrong, a flood, a fire, hailstorm, whatever it might be. A catastrophic insurable loss is any event that costs $25 million or more, and the Insurance Bureau of Canada adds this stuff up and plots it out as you see here as a function of time. And what's meaningful here, and this comes right down to you, the homeowners, this is highly, highly relevant, is that from about 1983 over to 2008, the industry could count on paying out, in terms of total insurable claims, catastrophic loss claims, about $200 to $500 million per year. They were down in this zone, with the odd anomalous event like the Eastern ice storm in 1988. However, from 2009 onward, the situation has changed. For 7 out of the last 8 years, and now it's going to be for 8 of the last 9 years, because I've seen the data for 2017 and it's bad, we've gone over $1 billion per year in terms of insurable loss claims on an annual basis. The curve is bending up. And the factor that's driving that to the greatest degree, that explains about 58% of the upward bend in this curve, is too much water in the wrong place. It's flooding. Flooding's the animal in the country, and flooding basements. And what that has done now, and I guarantee it's happened in this community, it's creating now this situation, an uninsurable housing market in Canada, where the insurers are pulling back on offering insurance for homes that are in areas that are at high risk of flooding or realized repeated basement flooding, because the risk of future flooding in these localities, based on past, is such that the premium that they would have to charge to cover the risk is so exorbitant, nobody could afford it. It's cost prohibitive. So, the threat, and I get calls from mayors and councillors from across Canada, maybe not once a week, once every 2 weeks, from somewhere in Canada who are in a bit of a dire state when they call, saying, what do we do in our community? Because my constituents, they're losing their house coverage, their insurance coverage for basement flooding of water of any type, whether it comes up through the sewer system, through the little drain in your basement, or overland flooding. And as Diane alluded to, the average cost of a flooded basement right now in Canada, in urban, suburban zones, is about $43,000. So if you have a basement flood, and remember, this is pretty nasty stuff. A lot of the time, this is sewer water. If you have a basement flood and you've got three feet of sewer water in your basement and you've got no insurance coverage, what do? 48% of Canadians, according to the Canadian Payroll Association, have a maximum of $250 of disposable income on a monthly basis. In other words, they don't have this money sitting around to remedy this problem without insurance coverage. And indeed, so now what we're looking at is to see whether or not we see spikes in mortgage defaults, mortgage errors, where people actually default on their mortgages because when they get a flooded basement with limited insurance coverage or no insurance coverage, they simply can't pay to solve the problem. They can't stay in the house because this is 3 feet of sewer water in the basement. So this is really, really nasty stuff. I'm not trying, we're not pubs, so I'm not trying not to elaborate too much, but this is sewer water, if you get my point. And so they're out of the house and paying to be somewhere else, and there's realizing a devaluation on their property while it sits with sewer water in the basement. So with the Royal Bank right now, I'm running a little bit of a study where we're looking at about 25 cities in Canada that have experienced repeated basement flooding, and we're now watching when the next storms hit those communities, we're looking for spikes in mortgage errors. So we really, the biggest threat to the Canadian housing market right now, it's not a 25 basis point rise in interest rates, it's basement flooding. That's the formidability of the challenge. So the question is, what do we do about this? And I'm just going to show, just to beat the point to death of how important this is. What you're looking at here from 1900 up to more or less the present, over the course of the last 100 years, you're looking at average rainfall in Canada over the period of the last 113 years. And so the horizontal axis here, that would be the average, 0. And you can see during the first part of the century, we were getting less rain than the average, but now, where you see the green bars, we're getting more rain today in the second half of the century than was previously the case. So right now in Canada, throughout southern Canada, due to climate change, this is the driver, period, we're getting about 18% more rain on average throughout southern Canada on an annual basis as compared to just over 100 years ago. So this is real stuff, but it's going to get worse going forward, for sure. We're not going backwards on climate change. And even with all the depressing stuff you heard so far, I could go on and on and on and give you a whole bunch more facts that make it even worse. But it's here to stay, it's not going away, and that's the way it is. So, the question is, what do we do about it? Now, clear, please. Yeah. So now what we're doing, in Canada right now, just forget the slide for a second, We are actually developing at this moment, I have my hand in these things fairly strongly, working with National Research Council, Standards Council of Canada, and the Canadian Standards Association. We're creating a number of standards for the country to guide development going forward to make it such that that development is flood resistant, not flood vulnerable. We're creating a new standard, I'll come to this, what's on the screen here in a second, but we're creating a new standard right now for new flood resilient community design. And this involves people, about 100 people, engineers, municipal planners, builders, conservation authorities, insurers, etc., from right across the country. We're developing a standard right now that will be such that when we build new residential communities going forward, there will be about 20 features built into them that with these features in place, the probability of realizing flooding in those communities going forward when the big storms hit is very much reduced as opposed to if you didn't put these features in place. And by the way, the cost of building a community right under the umbrella of adaptation to climate change is about the same as the cost of building it wrong. But if you build it wrong and then have to retrofit, it's enormously expensive. So that's one new standard being developed there that already, even before having the standard finalized, Madame A. Homes has bought on to using that standard to guide their developments. The city of Ottawa is now using that as guidance, Pristine Homes and other developers. And by the way, if you buy a home in these communities built to this standard, you will realize about a 5 to 15% on your insurance premium for your house, as opposed to if you built a home that's not built in a community as per that standard. And by the way, I'm not guessing about this. I work very, very closely with the insurance companies. Then we're creating a second standard, just signing off on it right now, to create a second standard for Canada for existing communities. What can we do within the context of existing communities to make them not so flood prone? Through the application of diversion channels, berms, holding ponds, bioswales, dry ponds, cisterns. There's things, permeable surfacing within communities. There's ways you can take existing communities and make them less flood vulnerable. And by the way, these are all cost savers. It's far better off to be proactive and ahead of the curve and not have the problem as opposed to management by disaster. You let a disaster occur and then everybody runs in and figures, well, how are we going to fix all this, right? The best way to solve the problem is don't have the problem. Now, the other standard we're working on right now is a standard that will be complete very, very shortly. It's a home basement flood protection standard. And what it amounts to, in short, is it's guidance to a homeowner that can be brought to them by a properly trained individual who will come to your home, and over the course of about an hour, hour and a half, took about an hour and a half to do my house, you first walk around the outside of the property and then you enter into the basement, but the homeowner has to be there with a person properly trained in home flood protection who will be pointing out to the homeowner potential vulnerabilities around the outside of their yard as to ways that water could enter into your basement, and documenting these, and then it all goes into a very user-friendly report. So it's things like, and by the way, this is not the physics of curved space. This is pretty straightforward stuff. This is things like taking the downspout from the east trough system and disconnecting it from the weeping tile system, just cutting it off, putting an elbow on it, and directing the water three meters away from your foundation and not into your neighbor's basement. It's things like plastic covers over window wells, so when the big storms hit, the water doesn't fill the window well and then go into the basement. It's making sure that the windows at grade level are watertight, such that water does get up to the side of the house, it's not going to flow into the basement. It's as simple as contouring around the house to direct water away from the foundation versus towards it. Then you go into the house and walk the homeowner through vulnerabilities that if water did get into the basement, how do you minimize the damage? So it's things like, for example, and by the way, there are about 50 or 60 of these things. I just put a few here for illustration purposes. It's if you have a sub pump, for example, do you have battery backup supply for that sub pump? Because the time you need the sub pump to work, to pump the water out of the basement, the excess water, is when the big storms are occurring, and very often that's when the electricity goes out, so the darn sub pump doesn't do you any good. You want to make sure that you've checked your sub pump, that it's not seized, that it actually works at the time you need it. Matter of fact, you should have 2 sub pumps. You could have the installation of backwater valves that make it, if the sewer system became overwhelmed with water, it doesn't back up through the sewer system piping and into your basement. And so through a multiplicity of factors like that, that for the average homeowner, when you conduct this assessment, we've done it for hundreds and hundreds of homes now in Burlington, Oakville, Toronto, Saskatoon, and Windsor as trials, you find that for the average house, there are about 6 or 8 things that show up that are problematic that can affect basement flooding or risk of basement flooding. 3/4 of the time, the average homeowner he or she can do themselves on a Saturday and maybe a Sunday morning, they can fix 6 out of 8 of these factors themselves for usually less than a couple of $100. And that being the difference between having a $50,000 or $100,000 basement flood versus not. It's amazing how much risk we can take out of the system very, very simply just by exercising a little bit of due diligence, a little bit of preparedness. And then if you do need a specialist to come in and help you, say with a backwater valve, to spend $1,000 there is pretty good, considering that you may be avoiding a $50,000 or $100,000 basement flood. And remember, every dime that you spend to protect your property through a system like this is pure equity in your house. This is something that you highlight to whoever it is that might buy your house somewhere down the road. And it's often amazing to me, for the average homeowner, they will put more effort into planning their vacation than they will into looking at how do I protect the primary investment vehicle in my life, which for most people is their home, from basement flooding. So, my suggestion for Sault Ste. Marie, I think which city I was in because I traveled so bloody much, I would seriously consider launching a home flood protection program in this city. It's highly doable, it works. The return on investment, by the way, is for every $1 invested in that program, you save about $13 over a period of 10 years in basement flooding that now does not occur. And the major insurers are recognizing this program in reference to, if you apply it, you can demonstrate that you've applied it, document it. Your insurer, most of the major insurers now will give you somewhere between a 5 to 15% reduction in your insurance premium. The average household insurance premium is about $1,200 per year. So right away, even if you spend a few $100s on it, within 2 or 3 years, you get your money back. And plus, that's to say nothing about the fact now you don't have your basement flooding. So, on that note, thank you very much.